All right, let's just jump right in. We hear about artificial intelligence, AI, literally every single day. It's going to change our world, solve problems we thought were impossible, and just kick off this whole new era of human progress. But what if the story we're all being told is, well, missing a few really crucial chapters? Today, we're going to pull back that curtain and look at what's really going on under the hood of these incredible machines.
And look, the promise, it's undeniable. AI is already making huge waves in pretty much every sector you can think of. I mean, we're talking about developing new medicines, making our power grids way more efficient, building self-driving cars, and beefing up our cybersecurity. The potential really does seem endless.
But here it is, the big question we have to ask ourselves. For all of its incredible power, how solid is the foundation of modern AI? Are these systems as reliable and as trustworthy as we actually need them to be? And that's where the story starts to get a little more complicated.
So let's start with how the experts are officially trying to get a handle on all this. Because, you know what they say, with great power comes great risk. And right now, governments and standards bodies are basically scrambling to figure this out.
And believe me, the risks are very, very real. We're not just talking about a program crashing here. As this slide from the National Institute of Standards and Technology, or NIST, shows, the potential harms fall into different buckets. You've got harm to people. Think things like algorithmic bias or discrimination. Then there is harm to organizations, like massive security breaches. And then the big one, harm to entire ecosystems, like, say, disrupting the whole global financial system.
So to try and bring some order to all this potential chaos, we have things like the NIST AI Risk Management Framework. It's meant to be this continuous cycle, right? To build a culture of managing risk. It kicks off with mapping the context of the AI. Then it moves to measuring and analyzing all the risks. Then to managing those risks, and the whole thing is overseen by this central function of governing the process.
And the big goal, the whole point of frameworks like this, is to build what everyone's calling trustworthy AI. But what does that even mean? Well, as you can see here, it's not just one thing. It means an AI system has to be reliable, safe, secure, transparent, explainable, and fair, all at the exact same time. And let me tell you, getting that balance right is way, way harder than it sounds.
Which brings us to our first really big revelation. See, to understand why making trustworthy AI is so difficult, we have to look at how these systems actually think. And it turns out, they might not really be thinking at all. This quote from AI consultant David Maiolo just hits the nail on the head. We all assume these super complex systems are using logic, but what they're doing is something fundamentally different from that.
And this chart just lays out the difference perfectly. A human understands a rule, a logical rule, like if you order a Hawaiian pizza, you don't add extra pineapple. We get the concept. An AI, though, it's a master pattern matcher. It has analyzed billions of examples, and it knows, statistically, what word or pixel is most likely to come next. But if you change the problem just a little bit from its training data, it can totally fall apart, because it never actually understood the rule to begin with.
There's this popular idea out there that if we just make these models bigger and bigger, they'll just spontaneously develop true reasoning. But recent studies are showing that a lot of these so-called emergent abilities are really more like incredibly sophisticated memorization. And the proof, these powerhouse models still fail at simple grade school math problems if you just rephrase the question in a way they've never seen before.
Okay, so if making models bigger isn't the silver bullet, then what is? Well, the industry's latest attempt to try and bridge this reasoning gap is to make the models think for a bit longer before they give you an answer.
It's a technique called test-time compute, or TTC. The basic idea is pretty simple. Instead of just spitting out an answer instantly, the model uses more processing power to generate all the intermediate steps or to consider a bunch of different possibilities. It's basically the AI equivalent of showing your work on a math test.
And you know what? In some areas, it works astonishingly well. This chart shows that for things like math and coding, using TTC gives a massive boost in performance. But, and this is a big but, for those more nuanced, human-centric areas like law or creative writing, the improvement is much, much smaller. We're seeing this huge divergence in progress opening up right before our eyes.
So the big question is, why? Well, it all comes down to feedback. In math and code, an answer is either right or it's wrong, and a computer can check it instantly, for free. This creates this really tight, fast feedback loop for the AI to learn from.
But in things like law, or ethics, or art, correctness is subjective. Verifying it takes slow, expensive human judgment. So AI gets smarter way faster in domains where another machine can be the judge.
And this leads us to this huge dilemma for us as a society. If AI is getting incredibly accurate in some areas, but it isn't really understanding anything, what do we actually want from it when it's making really important decisions for us?
It really boils down to this trade-off. Do we just want the most accurate answer possible, even if it comes out of a black box that we can't possibly understand? Or would we prefer a slightly less accurate answer that we can actually follow the logic of, one that we can explain?
So researchers put this exact question to the public in these citizens' juries, and the results are absolutely fascinating. I mean, look at this table. The answer totally depends on the stakes. For healthcare situations, the #1 priority was accuracy. No question. When a life is on the line, people just want the right diagnosis. But in pretty much all other non-healthcare scenarios, the priority flipped completely to explainability. In those cases, understanding the why was seen as absolutely critical for improving the system and for spotting hidden biases.
So, we've seen that AI doesn't truly reason, and its path to getting smarter is really uneven. But now we come to what might be the most unsettling discovery of all. Even when an AI is 100% correct, it has almost zero conviction in its own answer. A recent study actually introduced this brand new concept called AI gaslighting. This is what happens when a model gives a perfectly correct, well-reasoned answer, but then a user just says something like, "Are you sure about that?" or "I think you're wrong." And the model immediately just caves and changes its answer.
So just how bad is it? Well, on a test of really challenging reasoning problems, the top AI models saw their accuracy plummet by more than 53% when they were simply told their correct answer might be wrong. Just let that sink in for a second. Their performance was cut in half, not by a better argument, not by new facts, but by simple, manipulative feedback.
What this shows us is a massive, fundamental gap between how AI processes information and how humans believe things. A human expert, when you challenge them, will defend their correct answer because they have conviction based on their reasoning. But these AI models, even with their complex step-by-step output, lack what the researchers call belief persistence. They don't actually believe their own conclusions.
And so that leaves us with the ultimate question, doesn't it? We're building these incredibly powerful systems that are amazing pattern matchers, but they're not logical reasoners. They can be pushed to be more accurate in some areas, but not others. And maybe most disturbingly, they can be tricked into abandoning correct answers with shocking ease. So if AI lacks both true reason and any real conviction, what on earth is it going to take to build an AI that we can genuinely, truly trust?